Okay, today's lesson is exponents. Let's start with something you're familiar with, something we did earlier in the course. If you add 5 sevens together, instead of writing it like that, it's easier to say I have 5 sevens, or 5 times 7, which of course is 35. That's where we multiply. On the other hand, what if I multiply 5 sevens together? There should be some way to express that in shorthand, just like we express this in shorthand. Is there a way to do it? And of course, I wouldn't be asking the question if there weren't. Here's what you do. You write 7 to the 5th power. That's what that means. It means you just take 7 times itself 5 times. So, for example, 10 to the 4th is 10 times 10 times 10 times 10, which gives you 10,000. Every time you multiply by 10, you add 1. If you have 10 to the 1st power, that means just 1 10. Just like any number to the 1st power is just that number. If you have negative 2 to the 3rd power, that means negative 2 times negative 2 times negative 2, which is what? Negative 8? It's negative 8. If you take negative 2 to the 4th power, you're going to have negative 2 times negative 2 times negative 2 times negative 2, which is what? You're going to get positive 16. Agreed? And I think we already talked about this, but if you have negative 2 to the 3rd power, that's different from this. If you want to first take the negative and cube it, this is what you do. If you say negative 2 cubed, then everyone agrees that you first cube it and then you take the negative. So this is going to be the negative of 2 times 2 times 2, which is negative 8. Okay? Let's see what else we have. If you have 3 times x to the 7th, same thing. You do this first and then you do this. So this is going to be 3 times 1, 2, 3, 4, 5, 6, 7. That's what that stands for. On the other hand, if you have 3x like this to the 7th, that's going to be 3x times 3x times 3x times 3x times 3x times 3x times 3x. Okay, I shouldn't have used such a large number. Okay, which, if you multiply that all out, that's going to be 3 times 3 times 3. It's going to be 3 to the 7th times x to the 7th. Okay, so that's true. Okay, very good. As long as we're talking about that, let's just say what happens if I have a times b all to the n power, or I don't know, let's just say to the 3rd power, just to make it simple. It's going to be ab times ab times ab, which notice is going to be a times a, which is a cubed, b times b, which is b cubed. So when you have the product of things all cubed, it's the first thing cubed times the second thing cubed. Similarly, if you have a divided by b, well, we'll get into that later, I guess. Okay. So anyway, very good. So so now what else can we do? I guess I better keep track of my notes here. If I have 7 to the 5th times 7 cubed, okay, what's that going to be? That's going to be 1, 2, 3, 4, 5. That's what this stands for. This stands for that. And notice that's just 7 to the 1, 2, 3, 4, 5, 6, 7, 8. 8th power. So if I have one thing to a power times another thing to a power here, you just add the powers, add the exponents, and you're going to get 7 to the 8th. Okay? If I wanted to write this in general, I'd have a to the n times a to the m is a to the n plus m, like that. Okay? Whatever number that is, you add the exponents. Okay? What happens if n is equal to 0? then you're going to get a to the n times a to the 0, and of course that's equal to a to the n plus 0, what we just learned up there. And a to the n plus 0 is just a to the n. So a to the n times a to the 0 is a to the n. That must mean that this thing is equal to 1. So a to the 0 must be equal to 1. See that? A to the n times a to the 0, using this rule, is equal to this. And that's equal to this. So that must mean that a to the 0 is equal to 1. So any number to the 0 power is equal to the 1. Okay? Here's another question for you. What does, let's go back to 7 to the negative 5th mean? What does that mean? What does that mean? Well, 7 to the 5th times 7 to the negative 5th is equal to 7 to the 5 minus 5, which is 7 to the 0, and 7 to the 0 is equal to 1. So now I can divide both sides of the equation by this and get 7 to the negative 5th is equal to 1 divided by 7 to the 5th. See that? So anything to a negative power is just 1 over that thing. 7 to the negative 5th is 1 over 7 to the 5th. A to the negative n is equal to 1 over a to the n. You flip it over the line. You flip it over the line. Okay? So that's important. All sorts of important stuff. Okay? Let's see. I guess I better get rid of some of this now. In order to have a little more room. What else do I want to do? Let's just practice a couple of these things. What if you were to multiply these two together? 3 to the negative 1 times 4 to the negative 1. What's that equal to? Well, that's 1/3. This is 1/4. Remember how you multiply numbers? You multiply the tops, multiply the bottoms, and you get that right there. Okay? What happens if I want to add these two numbers together? Okay? Well, this is again 1/3. This is again 1/4. Now you need to get a common denominator. Remember the common denominator? 1/3 is the same as 4/12. 1/4 is the same as 3/12. So now that you have that common denominator of 12, you can add the numerators and get 7/12. So notice again, multiplication is usually easier than addition. Addition doesn't have all the nice things to it. Okay, let's do another one. Again, in class you'll be doing all sorts of examples like this. This is just to kind of get you started and give you an overview of what you'll be doing. So this is equal to 5 to the 7th times 5 to the negative 3rd, right? Because this is the same as 5 to the negative 3rd. Now you can add the exponents and get 5 to the 4th. So there's your answer. And notice, I could have gotten it this way too. 5 to the 7th over 5 to the 3rd is equal to what? 1, 2, 3, 4, 5, 6, 7, all being multiplied. And on the bottom you have 5 times 5 times 5, all being multiplied. Since everything's being multiplied, I can just cancel those out. And notice I get 5 to the 4th. See that? So that all makes sense. So the property is that a to the m divided by a to the n is equal to a to the m minus n. You take that one, subtract that one. Okay, very good. Let's do some more. What if you have 7 cubed all squared? What's that equal to? That's not the same as this now, right? This is this times that. We know that that's 7 to the 5th. This is saying I take 7 cubed and I square. What does that mean? That means I have 7 cubed times 7 cubed. Well, now I can add it like down here, and that's going to be 7 to the 6th power. See that? Similarly, if I have 5 to the 4th, quantity cubed, what's that going to be? That's 5 to the 4th times 5 to the 4th times 5 to the 4th. And so I have 4, 8, 12 of them all together. 5 to the 12th. So notice all you do is you multiply that. A to the m all to the n power is equal to a to the mn. Just multiply it. Okay, very good. This is the one I was getting at earlier. Let's look at it again. What if I have a times b all to the n power? Okay, well, that's equal to what? That's equal to ab. Let's make it to the 5th power, or 3rd power. Let's just keep it easy. ab, ab. Well, now, with multiplication, you can multiply in any order. So this is a times a times a is a cubed. B times b times b is b cubed. So notice that a times b all to the n power is just going to be a to the n times b to the n. Similarly, if you have a divided by b all to the n power, that's going to be a to the n divided by b to the n, because you're just multiplying each one of those things. Okay? Very good. So really, this is all there is to this section. It's just all the powers of exponents. One thing that the author doesn't do, but that I think is maybe kind of important, remember when we talked about square roots, we mentioned that you can write this as 7 to the 1/2 power. And the reason why that makes sense to write that as 7 to the 1/2 power is because, what is this? This is a number that when you multiply it times itself gives you 7. And notice that if I take 7 to the 1/2 power and multiply it by itself, that's going to be 7 to the 1/2 plus 1/2. 1/2 plus 1/2 is 1, and that's just 7. So that's why it makes sense to do that. Similarly, if you have the cube root of 7, you'd want to write that as 7 to the 1/3 power. Why? Because this is the number, by definition, that when you multiply it by itself 3 times, you get 7. And if I take 7 to the 1/3 times 7 to the 1/3 times 7 to the 1/3, that's going to be 7 to the what? 3/3 is 1, which is 7. So that makes sense. That makes sense to write it like that. And then you can also do things like this. You can talk about 9 to the 3/2 power. 9 to the 3/2 power you can think of as 9 to the 1/2 power, all quantity cubed, right? Because this thing to raise to this power is going to be 9 to the 3/2, and there's your 3/2. So this is just equal to the square root of 9 quantity cubed. The square root of 9 is 3. 3 cubed is 27. So you can write it like that. Okay? If you wanted to, you could write 5 to the 2/3 power. What does that mean? That means 5 to the 1/3 power, all squared. 5 to the 1/3 power is the same as the cube root of 5. And so you could think of it like that. Okay? Also, if you wanted to, you could think of this as 5 squared to the 1/3, because 2 times 1/3 is 2/3 again. And so now you can think of that as being the cube root of 25. So either one of those work. Okay? Either one of those work. Very good. So that is section 7.5, exponents.